Kia ora, everybody. Fantastic to tell you the next part of Visible Geology, the software and the functionality of it. Rachel is going to take us straight into it. This is a deeper dive into some of the features which are really more for university level students. But Rachel, take us where you're going to take us, and everybody, just appreciating that you're here. This is a fantastic thing to stick with. If you're new to this area that we're talking about, follow along, because it's quite another branch of geology that most people don't know about.
Awesome, cool. So I will just share my screen and we'll get going. Awesome. So what we're going to start with today is an anticline fold, sort of set right in the middle of the model here, as we can see, purple, green, light green, and blues and reds on top. And we've got some topography put in there as well, so we can see the surface expression of these. So it's a very simple fold with folded limbs off to the west and off to the east. And what I'm going to show you today is the next sort of icon where we left off. The last time was around the cross-section and the core samples. And this next little icon down at the bottom right-hand corner has a little strike and dip icon down here. So you click on that and you get what's called a decal. So this is basically a tool to take a structural measurement on your model, which is super cool. So let's see how it works. So when you click on new, you get a crosshair handle or manipulator popped into the scene, this red one here. If I zoom in a wee bit, you can see it's reading 1.05, which is essentially nearly horizontal, because essentially we're at the very, very top of the fold, or the fold hinge, which is nearly horizontal, so it's got no dip. So if I move this off to the east, we can start to see that something's happening. First of all, the map symbology, which should be familiar to people who have been doing some structural measurements in the field already, we can see the strike and dip information pops up here, and we've got a new label readout, which is 42.76. So very accurate. And if we tip that up, what we can see is this measurement is being overlaid or imprinted onto the surface of your model, despite what the topography is. So I could change the topography here, and it would correspond to plotting or mapping onto the surface of your model. And it sort of projects down to show you where it's just hovering over the surface, and projects down to show you kind of where it's actually taking its measurement from. And if you tip the model up so that you can kind of see this fold structure that's happening in the subsurface, we can see it does indeed sort of correspond quite nicely. It is dipping off to the east, and it is roughly about a 45, or as it's reading out there, a 42, 43 degree fold limb. So I'm quite happy with this measurement here, so I'm going to click the apply button. When I click the apply button, I get a readout of what the beds are doing. Now, the 000 obviously corresponds to the strike, which, as you can see, it is striking north-south. So bang on there with that reading. And then we have a rounded figure of 42 for the dip. So a really nice numerical representation of the structural measurement that we've just plotted on our model. And we can do things like, hide it or show it. We can go back and edit it, or we can bin it as well. So I'm going to add another one. So again, I click new. It starts off in the middle of the model. And what I'm going to do this time is click and drag this off to the west. And again, you can kind of see that as I was dragging it there, the map symbology was updating dynamically to show me where those beds were dipping. So on this side of the fold, as you may have predicted, we're going to be dipping off to the west, roughly at a kind of a similar angle. So here we have so I'm moving it around again, and you can see 42, 40, 32, etc. But it's all dipping off to the west. When it settles, it's settled now on a 40. So what that is measuring is the contacts of the first bed first bedding contact that it comes to at depth. So this is not a topographical measurement. This is a structural measurement of the lithologies that we see in the subsurface, which is super cool. So again, happy enough with where that's plotted there. I've got my second fold or second structural measurement, which is here. So now this is actually read a little bit differently. So it's reading the 180, which is interesting, and then dipping to 40. So both are technically correct. So that's pretty cool. And so let's just do a third one. Let's pop this one right over here, and maybe we will see it picking up. Okay, so it's picking up on the fold, kicking back up into that kind of synclinal structure off to this eastern border over here. So over here, we can see that it's reading a 7.9 or an 8-degree dip. And as we can see, it is just in this kind of trough part. So you can imagine that that would be a relatively flattish structural measurement in these contacts over here. So I've got 3 of these now in my scene. I can... let me just fix that there. So I can, click them individually on and off. So I'm individually showing them, or I can just do a bulk on off as well. If I close that, they just persist in the scene, and I get this nice projection down to show exactly where on the surface they are picking up that reading. So that is how you use the decal or the strike and dip measurement tool. But the next thing I want to show you guys is, that's all well and good. We've got some structural measurements. What do we usually do with structural measurements when we take them and collect them in the field? Well, more often than not, we actually need to do some analysis on them. And where do we do that? We do it in a Stereonet. So exact same here. I can click on this, what we call a waffle icon down here, and we select our Stereonet. So the Stereonet pops into the scene. We get this nice UI that we've developed, which I think is really, really effective for understanding the concepts of a Stereonet. I'm not going to go into the teaching of the Stereonet today. We can maybe do some separate videos on that if people like. But yeah, so when you're in a top-down view, you get your standard sort of 2-dimensional graph here, north, south, east, west, with your strike measurements all around the outside. And when, you can pan it, but when you tilt it, you get the bowl, the 3D visualization of the bowl of the lower hemisphere Stereonet. What some other programs do is once you tip it into that 3D, you lose the 2D projection. We've retained the 2D projection because it's actually so useful for understanding the relationship between the 3D and the 2D plots. So this for me makes this a really powerful teaching tool when it comes to explaining what a Stereonet is, how you use it, and how you connect those visual environments in your brain, how you map that together in your brain. But what I want to show you here, I'm going to go back down into the 2D first of all, and I'm going to click this button here, which says Import GeoExplorer data. Now, remember the GeoExplorer is what we're calling the 3D scene. So I click on this, and lo and behold, I've got 3 measurements after coming into my Stereonet with 1 click. And these are the strike decals that I've just plotted in the onto the model. So remember the 42 bed off to the that was dipping off to the east, and then the 2 beds that I had on the west fold limb, one of them kicking back up into that synclinal space. So I've got the 3 here, which is awesome. Now I'm just going to turn 2 of them off because I want to show you guys a little bit of a clean visualization of what this looks like in that 2D, 3D combination view. So when I'm down in the 2D, it's your standard great circle. Again, remember, it was perfectly north-south because I didn't really make a very complicated fold structure there. So perfectly north-south. So it's plotting nicely down along one great circle. And it was roughly about 42 degrees in dip. So again, coming in here, plotting the pole here and the plane here. And tipping that up into the 3D, you can really get a sense of the 3D plane here, which is plotted on this side. It kind of corresponds nicely to, yeah, that fold limb was dipping off to the east. And there it is, dipping off to the east there at about 45, 42 degrees. And you've got the representation of the pole to the plane in 3D and in 2D all at once, which just gives such a powerful representation of what that pole actually is. I don't know about you guys, but this was always a little bit of a tricky one for for me to learn, and for my for the students that I was learning this at the same time. It did take a wee while for us to get our heads around like what that pole was and what it looked like in the 2D and in the 3D spaces. So I'll turn the two other ones back on just to give you a look at what the three of them look like in the scene. So that's what it looks like there. Now, so I think that was pretty cool, but let me show you some more. So when I go back into my model, I still have the three measurements here. Now what I'm going to do is I'm going to add an event. I'm going to put a dike into my scene, into my model. I'm going to make it a little bit thinner because it's quite thick at the moment. I'm going to pop it off to one side, and I'm actually going to tip or tilt this dike ever so slightly off to the east as well. So now I've got a perfectly, again, I haven't actually, I won't, or sure I will. I'll tip it a little bit as well to face northeast ever so slightly, right? So I've got a northeast orientated dike that's ever so slightly dipping as well. So I'm going to apply that. There it is, lovely in my model. Now what I'm going to do is I'm going to pop back into my Stereonet. So you'll see the Stereonet's been cleaned up. We will be persisting that data in the next release, so don't worry too much about that. But what I'm going to do is I'm going to click this button again. And now what you can see is I have the three strike decals and strike and dip decals that I've plotted manually. But I've also pulled in, this is also automatically pulled in the attitude of the dike. So I haven't had to do anything additional. I haven't had to plot a decal directly on the dike. I've had to do literally no additional work, but I get the attitude of the dike in here as well, which is pretty cool. So you don't have to do anything additional. So one last thing, I'll just pop into the scene to give you guys an idea of the full suite of things that will be brought through to the Stereonet from the model is the fault. And again, I will just pop the fault. Well, it doesn't really matter where I pop the fault. I will just maybe orientate it a little bit differently. Yeah, so we've just popped a fault in there. So we've got a little bit of offset of the fold, and we've see it up on the surface as well. And when I go back into the Stereonet and I click the import information, now you can see it's getting a little bit busier because we have the three structural measurements, and we also have the dike and the fault having been imported into the Stereonet there as well. So one of the things to note here as well, if you've a bit more eagle-eyed, is that my beds have actually changed in attitude. So now this is reading 354 to 40 and 158 to 42 and 327 to 08. And if we go back in, we can see that, well, yeah, that's actually accurate, right? Because we've faulted the model. So these things, the orientation and the dip of this side of the limb has actually changed a wee bit. So we've actually made some changes to the model, and that's just automatically updated in the Stereonet. So I think that's pretty cool. The one other manual thing I want to show you guys today in the Stereonet is the rake. So I can obviously, as well as importing the data or integrating the data from the model into the Stereonet, we can obviously create all of your usual styles of structural data in the Stereonet directly as well. So we can plot lines, planes. But today I'm just going to show you the rake because I think this by far is my favorite. I think this is really cool. So as you see, when I clicked on the rake icon, I get these controls, so I can determine where I want the plane and the pole to the plane to be. Now I can click there, and I also get some widget handles that come in. So if you're sort of saying, oh, that's kind of a hard one to plot, you know, you want directly to be able to specify the strike and the dip, you can do that. So you just click into the scene once, and then these handles come into the scene, or you can actually manually set it here as well. So if you were wanting a strike of 40, a dip of 25, so on and so forth, you can actually just pop it straight in there. I'm actually just going to change the color of this one so that it's a little bit easier to see, because what I want to show you next is the control for the rake. So if I hover over the green one, we can see the green corresponds to strike. So that's the green handle out here. And as we see, that's at 0.40 right there. And again, the dip, that corresponds to the red. So we can see that there, that's set to 25. Now, if I catch any of those handles and move them, we can see how that's moving in the scene like this. And similarly with the orientation, I can change that as well. In the 3D scene, we can see how that changes there as well. So now I've changed the strike to almost 20 and the dip to almost 40. So there we go. That's just to show you guys that how that's corresponding in the scene there. So you can play around with the camera angle so that you can get like a really good idea of how these are all interacting in the 3D scene and how it plots in 2D as well. So you just play around to see how you're going to be able to see that the best, kind of get that really stuck in your head as to how that's working. But the blue handle up here controls the rake. And now the rake, or really it's just a lineation, any like vector line that's plotted directly on the plane can be captured by using this rake option. And as you can see, as I'm pulling the blue handle around, you can see the lineation that is literally stuck on that plane that cannot come out of the plane. And you can see the pole that represents the lineation in the 2D as well, coming up and down that great circle. And I just think this is fantastic because, you know, this is not an easy concept to get your head around when you're talking about a lineation on a plane, or when you're talking about a pole that occurs on a great circle and how those two environments are connected. So say what we're talking about in real life could be something like a striation that's occurring on a fold limb, or, you know, maybe some fossil trace, or, you know, maybe some other structural texture, like, I don't know, like a boudinage or something like that, that you're recording, or, you know, maybe even something like I don't know, like parasitic fold hinge or something like that. So, you know, there's so many options that you could represent with this, but I just think it's a really, really powerful 3D, 2D visualization that I haven't really seen in other places. So I did just want to showcase that today. And then so when you're kind of happy enough with what you want there, you can click apply, and now you have a custom piece of information plotted on your Stereonet. So again, I can have my custom ones, which is this rake that I just put in here. And again, if I imported my information from my model, it comes into the imported there. So you can have imported structural data, you can have your custom structural data, and you can have all, and you can turn each of them on and off and so on and so forth. So that's what I kind of wanted to show. It gets a bit busy, but you can control how much you see and how much you show. And yeah, that's pretty much what I wanted to show you today, Julian.
Well, that's really fantastic, Rachel. So look, everybody, if this is something that you're busy with, that you use, or that you're learning about, we would love to hear your feedback about it. So on the link to the software, there is also a place where you can give feedback. I think, Rachel, that's true to say that you really love more comments from people, because you're in process of development. This is a beta version. And so it is your chance to have some input to say you love this, or you like another feature, or you're interested in something, or something's not clear. Thanks so much, Rachel. I think we'll leave it there, and we'll see if anybody wants a version 3 or on any other of the features that you've got. All right?
Yeah. Awesome. Thanks, Julian.
Okay. Thanks very much.
See ya.